bright future. Every student matters.
Hello students, let's continue the chapter visualizing solid shapes. So in today's lecture, what we are going to do, we're going to learn about 3D shapes and the figures. Okay, some of them you might have already done in your earlier grades. So some we are going to learn now. Right, so let us start. Just see here. We're going to talk about faces, edges, and vertices. I know you all are familiar with these three terms. Still, let us recapitulate that. So, what is a vertex? So, let us start with the face first. Okay, what is a face? All these 3D shapes, I say, they are made up of polygonal regions. Like here, the polygon is a rectangle. Right, in this figure here it is a rectangle, like somewhere it is square. So polygonal region are known as faces. Okay, now these faces meet at a line that is known as edge. Okay, so suppose this face and this face, they are meeting at this line, so this is an edge. So all the faces meet at a line that is called an edge. Now where the edges meet, suppose this edge and this edge, they're meeting at this point, so this is known as vertex. So these all are vertex. As we can see, there are 8 vertex in this, right? 4 on the top, 4 at the bottom. So these are known as your vertex. Okay, so just to see in all the figures we can see this one, this one, this one. So I think you can identify the vertices, the edges, and the faces. Right, so what are faces, edges, and vertices? So just to see on all these figures, the corner points where the edges are meeting, that is your vertex. Okay, where the faces are meeting, that is your edge, and this polygonal region are your called faces. Okay, so these are some of the figures which are 3D shapes. Now here, polyhedrons. So what we have in polyhedron is, just to see, we have this one top and bottom as same, or we see that we don't have curved or circular parts in polyhedrons, right? So these all the shapes doesn't have any circular part or any curved part, right? So they are polyhedrons, and these are not polyhedrons, right? So we have learnt about sphere, cylinder, and cone. Right, so these are not polyhedrons. Is that clear? So difference between polyhedron and not polyhedrons. So some of the thing that you need to learn is, we have learnt about sphere, we have a curved surface in that. In cone we have lateral surface as curved and the base is a circular part. In the cylinder also we have the lateral surface as the curved one. Right, but in polyhedrons we don't have any curved surfaces. Okay, so the difference is clear now. Now here see, we have certain types of polyhedrons, so we are going to discuss 2 in your grade. The one is convex polyhedron. So if you remember, convex polygon we have done, in which all the interior angle measurement is less than 180 degree, right? So here also the same concept is to be applied, the same definition is to be applied. All the interior angles for convex polyhedrons will always be less than 180. You see this one, you see this one, all the angles are less than 180. Right, all the interior angles are less than 180. But here if I talk of, suppose this angle, this is not 180, these are more than 180. Right, so these are convex polyhedrons and these are not convex polyhedrons. Right, let us move to the next one, which is a regular polyhedron. So what is a regular polyhedron? We know regular means equal. Right, we have discussed regular polygons also. So a polyhedron is to be said as regular if faces are made up of regular polygons. That means the polygons are identical. Regular polygons means all the sides are equal and same number of faces meet at each vertex. Same number of faces at each vertex, right? So here if you see, just see, this is a regular one and this is not a regular one. Why the difference is, its faces are congruent, all the faces are same. In this all the faces are not same. Second, okay, all the faces in this also are same. That means they're identical, they're congruent, yes, in both of them. Here the vertices are formed by the same number of faces. So this is the vertex, Okay, this is formed by 1, 2 and this 3. This is also formed by the intersection of these 3. Okay, but here this vertex, if we see, is formed by 1 at the back, that is second and third. So I would say first, second and third, like this. Then we talk of this is just the intersection of one and the second face, like this. So three faces meet at A. If we see at point A, three faces are meeting. At point B, there are four faces that are meeting. So these are not regular, these are regular. Regular means same number of faces meet at each vertex. So same number of faces at each vertex. In this figure they are meeting. So these are regular polyhedrons. Is that clear? Okay. So you get more about it when you practice a lot of question based on this. So you remember the properties, and that comes into the concept comes into uh, the concept comes into your knowledge when you learn it, right? So just see here. Two important members are there of polyhedron family that are known as prism and pyramid. So these are the two terms that we are going to use widely in your chapter, prisms and pyramid. So what is the difference between prism and pyramid? So they are polyhedron only, both of them. So just see, in prism you will have the top and the bottom as the congruent polygons. The same type of polygon they are made up of. If this is a square, this will also be square. If this is a triangle, the bottom one, the top one is also a triangle, you see, right? The top and bottom polygons are exactly same. But in pyramids we have a base, and with that we all the points or all the vertices of that face, all the corners of that face are connected to then one point, right? So this is a square pyramid, or I say rectangular pyramid, because the base is rectangular, and here the face I see the bottom is a triangular one. So this is a triangular pyramid, right? This is a triangular prism, we say, right? There is a difference. Just see triangular prism and triangular pyramid, the difference is there. So like this we define prism and pyramid. So the prism will have the top and bottom as same, right? Top and bottom faces are exactly same, and here we will have one base, and those all the points of that base would be connected to then one point, right, on the top. Okay, now when we say prism is a polyhedron whose base and top are congruent polygon, I told you this, whose other faces, that is lateral faces, are parallelograms in shape. So one more information to add is the other faces, these four faces that we see, front and back side and both the sides, so these are parallelograms, right? In both of the prisms that are drawn here, they are parallelograms. And if we talk of a pyramid, it's a polyhedron whose base is a polygon. So yes, we see the base is a polygon, right, of any number of side. It can be 4, it can be 5, it can be 3, but minimum with 3 we have, right? Polygons start with 3 sides, whose lateral faces are triangles. Always the lateral faces are going to be triangular. As you see in both of them, the lateral faces, the standing faces, those are triangular with a common vertex. So they have this common vertex, right? So this is how we define prism and pyramids. I hope the idea of prism and pyramid is clear. I know most of you might be familiar with it earlier also. Okay, so here we are going to discuss one question. Just to see, we have to write faces, vertices, edges, and then we have to add faces and vertices, and edges plus 2. This answer we have to write here. So see, V stands for vertices, F stands for number of faces, E is for edges. So here there is a cuboid. As if I draw a cuboid, just see. So we have to tell how many faces, how many edges, how many faces does it have. So we see 1, if I name it as A, B, C, D, then E, F, G, H. How many vertices do I have? 8 vertices I have in a cuboid. Faces are, just see, 2 are on the sidewards, 2 are in front and back, and 1 on top and 1 on bottom, right? So there are total 6 faces. And edges is how many? Just see, 1, 2, 3, 4, 5, 6, 7 and 8. 9, 10, 11 and 12, these tending ones. So how many edges? 12 edges, right? So F plus V, 8 plus 6 is 14 and E plus 2, that is 12 plus 2 is 14, right? Okay, next, triangular pyramid. So you can see here is an image for triangular pyramid. We have just discussed it in the previous question as well. So triangular pyramid they're asking. So the base is a triangular. Base is a triangular, or we say if base is a triangular shape or triangular polygon. Okay, so they're asking the number of faces in that. So in triangular pyramid you can see one is at the bottom, okay, and 1, 2 and 1 at the back. That means there are 4 faces. Then what about the vertices? So we see 1, 2, 3 and 4. 4 vertices we have. What about the edges? Okay, so just see 1, 2, 3, 4, 5, 6. There are 6 edges in it. So let us add faces and vertices. 4 and 4 is 8. And E plus 2, that is edges. Number of edges is 6. 6 plus 2 is students 8. Okay, I hope this is clear. Okay, now comes triangular prism. In the triangular prism, the top and bottom will always be triangular. You can see here, this one and this one are same. So how many faces do we have? Just see, one is top and one is bottom, that is 2. And sidewards we have many, how many? 1, 2, 3 and 4 and 5. These are there. So total, if we say, the faces are 5. Okay, what about the vertices? 1, 2, 3, 4, 5, 6. We have 6 vertices. And let's talk about the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges we have. So let us add 6 and 5 is 11. 9 plus 2 is 11 here. The next is pyramid with a square base. So it's a pyramid, the base is square. So how many faces? One is the square face, and how many triangular? 1, 2, 3, 4. So total, if I talk of, there are 5 faces in the pyramid with a square base. Okay, what about the vertices? 1, 2, 3, 4 and 5. There are 5 vertices and edges 1, 2, 3, 4 and 4 at the bottom, that is 8. Right, so 5 and 5 is 10, that is F plus V, and E plus 2, edges plus 2 is also 10. Okay, the last is prism with a square base. So we see prism with a square base is just like a cuboid. It can be a cube, it can be a cuboid. It will become a cube when these heights, this one and this one I'm talking, this become equal to this. But here they are not equal, so it is a kind of cuboid. So it will have 6 faces, 8 vertices, 12 edges, 14 and 14 here. Right, so we have discussed this. So one thing I want you all to notice here, the last 2 columns, they have exactly the same values. Right, that means we can say F plus V is equal to F plus V is equal to E plus 2 for all of these shapes that we have discussed so far. Or we can say that F plus V minus E is equal to 2. Right, so this is known as Euler's formula. What is this known as? Euler's formula. So the name is EULER, Euler's formula. What is Euler's formula? F plus V minus E equals to. This is known as Euler's formula, and if this is satisfied, this is applicable to all the shapes, all the polygons, all the polygons, I say, all the pyramids, all the prism, all the polyhedrons it is applicable to. So they should be satisfied every time, because we have observed that F plus V, that is the number of faces plus number of vertices, is equal to number of edges plus 2. So this is the formula that we are going to use in detail. Okay, here is Euler's formula. So what I told you is F plus V minus E is equal to 2. This is our Euler's formula. F is the number of faces, V is the number of vertices, E is the number of edges. Get that? So whenever we will add these two and we'll subtract the number of edges from it, we should always get 2. Then it is verified that it's a polyhedron.